Hello and welcome to this Math in About a Minute video. The focus of this video is going to be about geometry proofs, specifically those dealing with triangles. So let's get into it. A couple of things. Let's talk about the basics. So first things first, when we're talking about proofs, we're looking at usually what's called a two-column proof, where you're going to put statements, that's what the S stands for, here on the left, and then you're going to justify it with a reason. All right, now a good way to make a statement is, or to think about a statement, is this is like an observation that you're making about whatever it is you're trying to prove. And then your reasons, it's a justification of why it works. Now, a couple things when it comes to triangles that are also worth noting is we have to know our letters. How can we determine if triangles are congruent? You have SSS for side, side, side. You have side, angle. You have angle, side, angle. You have angle, angle, side. And then you have hypotenuse and leg. This one only works for right triangles, however. Okay? And so our goal is, as we're going through trying to prove triangles are congruent, or doing something with triangles, is maybe to think about these combos of letters and what we have. So I have some examples later that we'll work through. So now, some tips. First things first, I would say either make or use your drawing. So if you have a drawing, totally use it. And then mark it up. So that's number one. Or number one is make it. Number two would be mark it up. And then three, apply, and I'm just going to say letters to it. And what I mean by that is try to make one of these things happen. As you start marking it up, you're going to see that some sides might be congruent. You might see that some angles are congruent. Try to match up with some of these letters so that you can prove it. And then four, this is going to be a tough one. You just have to be familiar with your facts. So you got to know what is what and how you can say it. Now, when I said observation up here, it's not something like you can just look at and be like, well, it kind of looks like they're the same, so that's good. You're looking at it, but then you're going to give it a nice solid justification to prove why it must be what it is. And so that's what that R again stands for, reason. You have to be able to provide a reason for why you think what you think. So let's jump straight into it now and look at two proofs. You're going to see these are very, very similar, but there's just a few subtle differences. And so I did that so we can kind of, have a little compare and contrast. So what I'm going to do is I'm going to make my two-column proof. Got my statements, got my reasons. Got my statements, got my reasons. Now, let's switch colors and have some fun. So first, I'm going to use the picture that's given to me. I'm told that AE is congruent to DE. So I'm going to put a line there. I'm also told that BE is congruent to CE. And then my goal here is to prove that triangle ABE is congruent to triangle DCE. And so just to kind of show you that, I'm trying to show that this guy is the same as this guy. All right, so let's take a look at how I can do that. Now, thinking about my letters, what I'm seeing is I have two sides. And the other thing I'm seeing, let's zoom on in here, is that I have a congruent angle here and here. And the reason why is that that's vertical angles. So now I pretty much have everything I need. The hard part is to articulate that. So let's start articulating it. First things first, start with what has been given to you. So I'm going to go with AE congruent to DE, and BE is congruent to CE. Oops, those are lines. And then my statement, or my reasoning, it's given. Now, I'm going to go on a limb and say angle AEB, so this angle right here, AEB, is congruent to angle DEC, DE and C. Why? It's because they are vertical angles. Now, sometimes you might get a little bit fancier, say it's the vertical angle postulate, definition of vertical angles, but really, vertical angles gets the point across. Well, now I've done exactly what I need to do. I proved that ABE is congruent to, or sorry, triangle ABE is congruent to triangle DCE. But how did I do that? I did it by going side, angle, side. So that's my justification, my reason right there, side, angle, side. Now, unfortunately, there's nothing we can really box and walk away. We just have to list it out like that. All right, now that's one. Let's take a look at another one. And let's go to the highlighter again. I like that. So we're trying to prove that ABC is, whoa, oh, yeah, that works, sorry, is congruent to DCB. All right. So those are a slightly different thing. Given some information. So step one, I'm going to use that information that's been given to me. AB is congruent to DC. So let's make it a little thinner here. AB, DC, congruent. I then have AC is congruent to DB. So these guys, these long lines right there, those guys are congruent. And that's all I have. Okay. Well, now I just want to point out that this angle, that doesn't help me. That's not part of it. So I can't be looking at that angle. What I happened to notice though is where I highlighted, say overlap right here. So I'm going to use that. Now, bear with me while I do this. First things first, let's go to the proof and let's start putting down some stuff. So I'm going to put down what's given to me. AB is congruent to DC. And AC is congruent to DB. That is given. Awesome. All right. Now, what I'm seeing, what I'm working for is I want to go with side, side, side as my sort of reason for proving these things are congruent. This is going to seem kind of weird, but I'm going to say BC is congruent to BC. Now, here's the method behind my madness. There is a BC on that triangle. And then there's a BC on that triangle right there. I'm saying that the BC from one triangle is the same BC from the other triangle. Now, this is since we're saying something is equal to itself, we're using what's called the reflexive property of congruence. All right, reflexive, it's very similar to like reflective, like think of a mirror, how something is going to be the same to itself. That's kind of what's going on here. Now we can say triangle ABC is congruent to triangle DCB. And why? What's our reason? S, S, S. And there we go. That's how we do some stuff with some proofs. A little bit tricky, takes a while to get the hang of it, but kind of follow these tips that I have for you. You know, make and use your drawing, start marking it up, and then once you've made some markings, start to apply some of those letters, you know, like SSS, SAS, whatever it might be. See what it is you have and maybe what you can find. Then just make sure you're justifying it by being familiar with those facts. So good luck with your homework or practice, and let me know if you have any questions.